What we're going to talk about now is we're actually moving into artificial intelligence and monitoring of operation using the artificial intelligence. I'm going to introduce my colleague Massimo Cicchetti, Head of Innovation and Efficiency at IATA, to lead, moderate the session. Massimo, please, welcome.
Thank you, Sean. Thank you, everyone, and good afternoon. So it's like the Oscar night. Now it's never ending. Let's hope that. So it's we have talked here about in the previous session about safety, efficiency, and security. One of the things we want to now go through is we know already that with the timestamps turnaround, we have solution with artificial intelligence that can deliver and track with cameras timing of events that may happen and at what time they happen, essentially. What we want to present, what we want to explore through my colleague here from Asaya, Christian Hen, Chief Customer Officer. Please, a big round of applause for him. So we want to explore here is that what are our opportunities to use the same type of technology with artificial intelligence, not only to track the timing of when an event happened for the purpose of having a turnaround time track and on time, but also how can we use this to track other type of events that are related to the safety of the events and are also embedded in our standards, such as the IGOM or such as ISEGO. So I will have to hand over to Christian. We have here some concept that he wants to present to us, and we have discussed that. Over to you, Christian, please.
Thank you, Massimo, and thanks for giving us the opportunity to talk about this exciting topic. Thanks for staying around, everyone. It's the last day after yesterday evening. Must not be easy. Speak out of experience. Few words about myself. So my name is Christian. I work as Chief Customer Officer with Asaya. Before joining Asaya, I worked 8.5 years at Amsterdam Airport Schiphol. In my last role there, I was head of innovation, and even though I felt I wanted to move to something else out of the airport, after 8.5 years, I wanted to stay in aviation, and I wanted to do something with technology and data. And that's when the Swiss company Asaya came by, and I kind of fell in love with them and was lucky that they were willing to have me. So at Asaya, I'm responsible for what we call customer success. So after we've sold a system and it's implemented, it's basically my responsibility to make sure that the customer receives maximum value from it. Today, as Massimo said, we want to talk not so much about the real-time part. I was quite happy to see one of the first presentations, this IGHC, was CAS telling how they use real-time data and want to use automated data in order to improve on-time performance. That's great. But there's another opportunity that we want to discuss today to basically use historical data to track compliance. There we go. So first of all, I'll set the stage a little bit, and then I'll introduce the technology. What are we actually talking about? And then we'll present the concept that we think could be very interesting. So first of all, why do we use audits and why do we use standards, right? So as also been presented by IATA already in this conference, I think it was also on the first day, the industry had 5.7 billion euros of damages in 2019, which is expected to double by 2040. And these are the astronomical figures, right? And coming out of a crisis, everyone being cash-strapped, I think these are interesting things. How can we sort of make sure that the costs don't go further up and we all go back to a situation of profitability? One sentence for us, very important: you can't manage what you can't measure. Right? So you need to have a very good understanding of what's going on if you want to make improvements. There's many initiatives, Lean, Six Sigma initiatives, optimization, software, tools, everything. And those are, we need all of those, don't get me wrong. But in the end of the day, those things can only be as good as they are if the data that goes into those systems and processes are accurate. Because if you have garbage in, you get garbage out. So from my own experience working in an airport, but also from what I've seen working with many airlines in the last 3.5 years, airside operations is pretty much a black box. And big strides have been made in what we heard just now, baggage tracking, passenger tracking with sensors in the terminal, but it's almost as if airside and the ramp is sort of the last bastion where nobody knows exactly what's going on, especially not in real time. And when we talk to airports and airlines, what we typically hear is challenges with safety, with on-time performance, with capacity, right? But that's the tip of the iceberg because that's caused by something. So if we look underwater, what do we see? We see airports and airlines actually having trouble making the right decisions because they don't have the right information and they don't know the impact of the decisions they make, especially not outside of their own domain. And if we look even further, what we see is that they just lack the data and information to make those right decisions. So that's why we come in, and that's what we're trying to address. So give them the right information to make the right decisions and address those problems of on-time performance, capacity, and safety. So moving on to the topic of audits, typically audits are done manually today. Not so much anymore with pen and paper, even though it also still happens, but on iPads, on phones, on tablet computers, those kind of devices. So a few words about the way we're doing it today is it's relatively labor intensive and therefore relatively costly. And I think especially in the last 3 days, almost every session has been about how difficult it is to get labor. So I think that's definitely a topic of concern. And if you have local audits, it still means that people will need to go to security checks to go out to the ramp. But even if you have people that fly around the world to do audits, it's even a totally different story, obviously. Then on the other side, if you do audits in the traditional way, the density of data that you get and the volume of data that you get is relatively low. Because if you got an auditor at one flight, he can see what's happening on one side, but he won't see what's happening on the other side. He won't see what's happening inside the jet bridge or inside the terminal, right? So the amount of data that you get, even if you do one audit, is by nature limited by what you can see as an auditor. On the other side, an auditor can only do so many audits a day, just by the sheer fact that you cannot be all the time everywhere, right? Then another thing is data quality. And I'll have a next slide to sort of back up my statement here that what we've seen is that humans are generally not created to create data, right? We've seen it over and over again where we sort of compare automated data generation versus humans who need to generate data, especially if these humans are also responsible for different tasks at the same time. It's just not a match made in heaven. And the last thing, representative data. I myself, did sort of security audits working in an airport where you would, carry a weapon or something else, go through security in order to sort of test the security stuff. The interesting part is the first time you go through a security checkpoint, it actually feels like, sort of the representative thing is happening and people are actually not expecting you and it feels like real. But what happens is all these people are in WhatsApp groups, they inform each other, and the second time you go to another checkpoint, they already know you're coming, they'll recognize you, and it's a totally different experience. And this happens in audits all the time, right? So representative data means that typically people know they're going to be audited, and the behavior will be different than if they're not know they're going to be audited. So we did a project with British Airways in 2019, I believe. And they got their turnaround coordinators basically taking manual timestamps for all of their turnaround processes. And for a few months, we compared the manual data collection versus what we did in an automated way. And this is the key outtake on which we also wrote a white paper. And the thing on the right, it basically addresses the real-time matter of things. So they're just not as quick. But I think for this discussion, it's interesting to look at the left side, where they basically only capture 60% of the data points that BA is actually interested in, and the automated system that we use actually captured 100% of those data points. And again, that's just by the sheer fact that they cannot be at different places at the same time. So what's that solution that we're talking about? AI, of course, big buzzword, but what is it we do? So we're a software company, and the software that we sell basically analyzes video streams. So we work with cameras overlooking the apron, overlooking aircraft stands, and these cameras are nothing special for us, and we actually prefer to work with existing cameras just to keep the cost and the investment for our customers acceptable. And the software basically looks at those video streams and can then identify events. And an event can be an aircraft coming onto the stand, an event can be a bridge connecting, a fueler showing up, it can be a person wearing a high visibility vest, it can be someone speeding. Those are all things that we can detect. And we often get a lot of questions, can you do this, can you do that? As a rule of thumb, if you as a human would be watching that video on a screen, everything that you could sort of visually identify is something that we can teach the system to also identify. Good example, we did a project with one of the major US carriers, and they asked us to detect cleaners, and we asked them, okay, so how would you know, if you were just looking at the camera, how would you know when cleaners come on board and it's not some maintenance crew, because they're all wearing the same vests, right? And they said, well, these are obviously cleaners because they're carrying a vacuum cleaner. Aha, right? So we calibrated the system to detect the crew coming on board with the vacuum cleaner as being the cleaners. Just as an example on how this works. And I think actions are always better than words. So at this point, I'd like to show you, to take you to Seattle and show you a little bit of the live system we got there. In Seattle, the Port of Seattle, so the airport invested in the system, but made it available to all airlines and ground handlers, right? So they all have access to this, to the data and to the application. And I'll show you a little bit around on sort of how this works. So this is live, and I'll just show you the video and enlarge it for you so you can actually see that. Obviously, we're in the middle of the night here. As I said, we work with existing cameras here. So we rolled out across 100 gates, the entire airport, based on existing camera infrastructure. That's sort of the first wave, and the port is now sort of assessing where do we see gaps, where do we not have coverage, and as a result of that, they will be implementing additional cameras. So on most stands, we'll have 2 cameras, one on the starboard side, one on the port side, and on some others, we also have a frontal camera. So this is the live video. This is the video basically that the software is looking at, if you will. And then below here, we can all see all the different processes and events that the system has detected. By the way, we got permission from Port of Seattle to show this here, so we don't show everyone's data, but we got the permission to do this right here. So one of the things, especially we're talking about compliance and in the safety domain, one of the things that we're tracking here is the bridge fully parked, right? So after a turnaround, if the bridge is not fully parked, that might pose a threat to the next oncoming aircraft, because if it's not in the parking position, it might hit the engine or the fuselage of the upcoming aircraft. So what we can see here is, we see that the bridge entered parking at 2:58 and it left the parking at 3:37. And in this case, we're just going to do a manual visual check here. So this is actually exactly 3:37:58. So this is when the system said the bridge left parking. And if I go slightly back, this is 1 second steps. We can see we're 3-4 seconds. Indeed, this was the moment that the bridge started moving from its parking position onto the aircraft. And this is just to show you that the system can actually very accurately detect when these kind of things start and end. Another safety-related thing is actually the placement of the tail stand, which especially for airlines was a safety problem because it was sometimes forgotten. Again, we can see here when it was placed. If I jump the frame to the moment it was placed and go forward in 1 second steps, we can see the guys here putting the stand under the tail of the aircraft. And then later on, if we jump forward, we can see here that this was the moment that the guy was actually taking the tail stand away. This kind of technology actually works the same as Google Photos or Apple Photos, right? So you have this photo application on your phone, and you can then say, this picture, this is John. And then your phone will give you another pictures and say, this is also John, this is also John. And one of them won't be John. You say, no, this is actually not John. So you're actually teaching the system what does John look like? And your phone will make up its own rules to say, John's the guy with the beard and, I don't know, the gray hair or whatever. And that's how the system works as well. So we've trained the system to recognize belt loaders, high loaders, fueling trucks, all those sorts of things. So far, the demo. I think from here on we can move back to the slides, please. So then, now that we've talked about audits in general, we talked about technology, then let's talk a little bit about this concept that we're thinking about. The idea is if we can detect everything that's going on, we might be able to automate audits to a certain extent. And we realize that this won't be a thing from today to tomorrow where we go from 0 to 100, but there's actually a very logical growth model. Because what we envision is that auditors can actually determine, what should checklists look like, what do we want audits to look like, and what do we need to audit for. The cameras then observe all the turnarounds, and not just selected turnarounds, but all turnarounds. The AI that's in some airports already there can then detect those events of interest, and the auditors basically get the reports, right? So that can be a PDF report, but it can also be a dashboard where you get the results, and not only do you see the results, you can click on the results, and as we just did before, you can get video confirmation of exactly what happened. So that's, I think, a great way where you can back up observations with video proof, basically. And the interesting part here is that, as I said, you might not be able to detect everything today, but there's already quite a lot that you actually can detect. And the interesting part is everything that you cannot detect, you can still have audited by a human on the video. We, for example, have what we call an annotation team. That's the people that, for us, are calibrating the system. So they're looking at turnarounds all day, every day, basically. And they're the one telling, this is John, this is not John, this is a high loader, this is a fueling truck. So these people are looking at turnaround videos anyway, and these people could be doing audit jobs in the mix with the other work that they're doing as well. They don't have to, it could be someone else as well, that don't get hung up on that too much. But it's a combination, so we can combine sort of manual video audits with AI automated audits. And just to show where we actually already are today, there's 3 of the major US carriers with whom we've actually already tried this. And you can see, first of all, very interesting that there's a really big difference of number of items on their audit checklists. And then also you can see what, how many of those items we've been able to audit with our Apron AI solution. How many we've been able to do manually, just by our people looking at those videos. And especially for the 3rd US airline, there was quite a lot of things that we just couldn't see because the camera infrastructure didn't give us visibility on that. So this to show that, even though this sounds advanced, systems like these are already live at airports across the world, and we're already doing these kinds of practices with several airlines. And just to give you a few examples, what are those things that we actually do, and what kind of data can we actually get? So one example, and again, this is with one of the larger US carriers that we did, is basically to track pushback speed. So they had issues that they had a lot of damages to the nose wheel of the aircraft, and they thought because it was of inappropriate pushback operations, and especially speeding. So what we did is we trained the system to track speed of the pushback tug in this example. And what you can see here is the pushback path and the according speed with the speed limit. And you can see that in the middle of the pushback, the speed is actually above the limit. And this, of course, is just one turnaround. But if you do this for all turnarounds, then you can sort of dive deeper. And I think that's a really interesting phenomena because everyone kind of knows, I guess, that data analytics is a really powerful way to find sort of why things are happening, right? So if you have a huge base of data, you can actually find connections why things are happening or in which cases things are happening. And again, if you have to do so many audits to do this kind of big data analysis, that's going to become really costly. But with a passive system like this, you're going to automatically collect all that data. So you can see here several comparisons where we looked at the speeding problem. Is it bigger at different times of the day? Is it related to shifts? Is it related to days of the weeks? Is it related to aircraft types or aircraft type and pushback type combinations? So you can dig super deep, and the bigger the data set you have, the more of these subtle cues you're going to find as to what's actually causing these kinds of unsafe behaviors. And in this case, so we didn't only look at was there speeding in a turnaround, or in a pushback, sorry, but also for how long were they speeding? Because if they were just speeding for 1 second, you'd say, okay, that's maybe just a human mistake, which is fine. But if you're speeding for 50% of the pushback, then then something is obviously wrong. And so we found that speeding is negatively correlated with several hours of the day and aircraft types like the CRJ. What is positively correlated with the other aircraft types like the 737, and it being a Sunday. And again, negatively correlated between the time of the day being the day as opposed to the night and the early morning. So, and these are all statistically significant findings. So that means that it's not just out of sheer luck, but there were like significantly more cases of speeding correlated to these kind of things. Another topic, wing walkers, highly related to safety again, of course. Standard procedure is to have 2 wing walkers at arrival and at departure for the airline that we did this with. And we can see, luckily, in most cases, that was actually the case. And there was actually no cases that there were no wing walkers present, but there were actually quite some cases where there was only 1 wing walker present, right? So again, I don't have those results here, but it's interesting to find out why is there only 1 wing walker present. And does this happen at certain days or at shift changes or at certain gates because it's further out, harder for people to get there? That's sort of the kind of information that you can try to dig into. Another thing that we're actually doing for many airports at the moment is what we call stand not clear. And this is a thing where, shortly before arrival of the aircraft, you want the stand to be clear so there's no GSE parked on the stand or anything else basically that could potentially be a threat to the aircraft, or if the aircraft sees it, makes the aircraft wait and therefore lead to OTP problems. And this is data from one of the airports we're currently working with, where we're showing for how many percentage of all turnarounds the stand is actually clear. And you can see that, first of all, it's fluctuating a lot, right? So ideally, you would want to see this percentage to be as low as possible. And I think the average is around, 2.5%. So that's, I'd say, not too bad, even though I think it should be maybe even better. But the weird part is that it goes from a good day where it's only 0.5% of the turns up to 4%, which is a really big difference. So that says something about the stability of the operation and the procedure and to what extent it's being carried out continuously at a high level. So one of the things related to stand not clear is obviously FOD. So we're not by any means saying that we do FOD checks, because typically cameras, especially existing normal cameras, they just don't give you the resolution to do that properly. So that's just not a claim we'd like to make, especially because FOD can also be just screws or small metal plates in the same color as the tarmac, which we just wouldn't see. But what we can do is see if a FOD walk by a human has been or has not been performed. And the way that we do it is that we'll agree with the customer to say, okay, before aircraft arrival, we need someone to walk the stand or walk the line. And for us, then it means someone needs to walk through this red marked area. And we can put this red marked area anywhere, and we can make it bigger or smaller, or we can make multiple ones. So this is just one example. And the way how we typically configure it is that we say, when did the aircraft land? And between the aircraft landing and the aircraft coming onto the stand, we have to see someone walking through that area. Otherwise, we'll say that the FOD walk was skipped. Some results from one of the airports in the UK, actually very significant, show that they went from having 60% of their turnarounds where one of the FOD walks was not carried out, and it went all the way down with 42% to around 35%. So that's a massive difference, which is not strange if you think about it, because the way we implemented this is that in the AOC, the airport would basically get the queue, would get the alerts when a FOD walk was not performed. They would call the ground handler. So if you're the ground handler and all of a sudden you start getting calls that you're not performing your FOD walks, you're changing your behavior, right? There's a psychological phenomenon that actually explains this, that says if you're being watched, you automatically perform better. And that's exactly what you're seeing here. And I think that just shows as to what are the impact you can make and the achievements you can get if you're measuring this not only on a few turns, but continuously and make it part of your continuous operation. So that's sort of the examples I wanted to show, and the concept we kind of wanted to introduce and share with you. So at this point in time, super happy to take some questions. Thanks.
Please, Christian. So you can type your question, or you can ask with the microphone. So I have this gentleman over here. Just a second, the microphone is coming. Should come. May come. It's not. Okay, just a sec. I move to the question that has been typed, then the microphone will come, so we'll give you the chance to go. So I like the concept. AI could help airlines and audit create trend-based risk assessment and audit need. How do you see the management of the data sharing? That's a very interesting question. Data privacy, data sharing, and things like that. Please.
Yeah, excellent question. So how we typically configure it is that we work with user groups. So also in Seattle, for example, the airport has access to all the data, but we're working with Alaska Airlines, for example, with Delta Airlines. They only have access to data for their turns. With regard to ground handlers, we basically create a matrix where we say if there's a ground handler responsible for several airlines, they only have access to the data of those airlines. So that's how we separate the data sharing between those groups. And that typically works well. For us, it's part of the implementation project where these topics needs to be discussed. But this is I would say the standard modus operandi that until now has worked everywhere. So yeah.
Okay, coming back around on similar topic to that, but what is the likelihood of this type of technology being abused, i.e. management nailing down on a person every time that they step in the wrong place?
Good question. So we'd like to say we're not tracking individuals' performance, but we're tracking process performance. And I think actually the more you track, or in case of audits, if you audit one flight, if something goes wrong, it was that flight. If you're looking at how do 100 flights from last week perform, it actually by definition becomes more anonymous, I'd say. So even though you can, of course, go back to an individual flight and you can find out who was working on that flight, I actually think this kind of solution lends itself more for analyzing the bigger picture rather than looking at a single operation or even a single person. And just to maybe add on to that, especially in Europe, obviously there's quite stringent data privacy rules. So we offer the option, and in Europe that's being used quite a lot, in the US not so much, to also blur out people, right? So if you're looking back at either the live video or if you're looking back at past video, we can basically automatically blur out people which actually makes it sure that you cannot even see which person is there. And yes, of course, you can say that was flight, I don't know, Delta 1234, go back to the schedule who worked on that flight. But if you're going to take that amount of effort, then you can always find out who did something, I think.
There's another question on the screen.
What is the scope of the physical evidence? Can it consider the hold area? What about data analytics, interview, and the documentation evidence tracking using the AI? So the first part, the scope, at the moment we work mainly at the aircraft stand, but there's no specific reason why we couldn't do the same thing beyond that. One of the US airports, for example, what we do is aircraft wait for park. So sometimes the gate is not ready or the VDGS is not on and aircrafts are holding. And we're actually detecting these holdings outside of the gate area. So I think that's a first step in that direction. I think the key thing is, do we have visibility through the camera on that area? So interviews, that's an interesting one because obviously cameras don't do interviews, right? And I think that's something that has to be separate. So I think you do data collection, and if you find something where you're going to get more information or detail or feedback from whomever was active there, I think that's a separate task that's not solved through using this kind of concept.
Any other question from the audience? I have one question for you, Christian. So you have here now displayed some proof, some concept here. So if we think about how long would it take for a company like yours to start to get into, I would say, more deeper implementation of some standards. As an example, I can say tracking speeds of ground support equipment in the equipment restraint area, track if they have connect to the aircraft or they have respect the no-touch policy, all this type of things. How much you think is achievable and how long would it take?
Yeah, it's a good question. And so I think a lot can be done like literally today, as actually some of the examples have shown, right? We are continuously adding also new things, typically based on customer requests, so it's sort of organically growing. And it's hard to give solid timelines, because tracking one thing can be much more difficult than tracking another thing.
Indeed.
But typically it takes us about, I would say, 3 to 4 months, where we say, when we start the effort to say, okay, we also want to be able to detect this or that, until we can actually do that in production. What I think is especially nice, if you take Seattle as an example, the application, the fundamental technology is all there. It's almost like you consider an app store. So the app store is there, and you can put new things on top. And as I mentioned, the original contract is with the Port of Seattle. Well, we're now also making deals with the individual airlines, because they have special requests specifically for them on top of sort of that basic functionality that the port is offering them already for free. So there's also a nice way to sort of mix and match it to everyone's individual needs.
And the last one for me, I do remember that you were showing that with a customer line, the system could not detect eventually whether there was a conformance or not, but could detect eventually that there was something unclear, and then it left, footage for the interpretation of a so-called auditor remotely to determine whether the procedures was performed correctly or wrongly, right? So you see also have an opportunity to provide eventually in the future some stuff that perhaps our auditor could have a number of turnarounds or a number of events that they can check remotely about a certain condition, whether they're met or not.
Yeah, absolutely. And some of you might have seen that on the screen when we were looking at the tail stand being removed. There was like a confidence level. So the system, besides giving you a timestamp, it also gives you sort of this confidence level, which is a quality mark or a certainty level that tells you a little bit about how likely is it that this timestamp is accurate. So especially for these kinds of purposes, you can say, hey, if I'm looking at, I only want to look at the ones where the system was very certain. Or alternatively, you can say the ones where the system wasn't certain, those ones I'll manually review myself in order to make sure that we don't get any false data into the analysis.
So thank you so much, Christian. I think we are come to conclusion of our session. Thank you so much for bringing us into this new data system and potential technology that we can eventually use, not just to track the timing when events happen, but also if those type of performance are performed safely and there's any particular issue, night and day, aircraft type, that can be further analyzed to understand where the problem is, and it's a dynamic flow of information as opposed to certain event that I observed just during certain time. So thank you so much for you. And
thanks for having us.
For it.
Have a great day, everyone.
Thanks.